Identify the thermodynamic state functions of the system. The question states that potassium nitrate, KNO3, dissolves endothermically. This indicates that heat is absorbed from the surroundings, meaning the change in enthalpy is positive, delta H greater than 0. Because the salt spontaneously dissolves at 25 degrees Celsius, the process is thermodynamically favorable. A thermodynamically favorable process at a constant temperature and pressure must have a negative change in Gibbs free energy, delta G, less than 0. Relate favorability using the Gibbs free energy equation. The relationship between free energy, enthalpy, temperature, and entropy is defined by the fundamental thermodynamic equation. Delta G equals delta H, T delta S, where T is the absolute temperature in Kelvin, 298 Kelvin at 25 degrees Celsius, and delta S is the entropy change of the system. Analyze the algebraic conditions for favorability. We know that delta H is positive plus symbol because the process is endothermic. For delta G to be negative minus symbol, the subtraction term, T delta S, must be positive and have a greater magnitude than the positive delta H term. Algebraically, since delta G equals delta H, T delta S less than 0, therefore T delta S greater than delta H, because T is always positive in Kelvin, the entropy change, delta S, must be positive, delta S greater than 0, meaning the entropy of the system increases during dissolution. Connect the math to particulate behavior. Solid potassium nitrate, KNO3, consists of K to the power plus and number 3 to the power negative ions arranged in a highly ordered, rigid crystalline lattice. When the salt dissolves, these ions break free from their fixed positions and disperse randomly throughout the aqueous solvent. This transition from a highly ordered solid phase to a highly mobile, dispersed aqueous phase represents a significant increase in the positional disorder of the particles, causing entropy to increase, delta S greater than 0. At 25 degrees Celsius, this entropy increase is large enough that T delta S exceeds delta H, driving delta G negative and making the dissolution favorable. This identifies option D as the correct choice. The correct answer is option D. The entropy of the system increases during the dissolution, so T delta S is greater than delta H.